All right. How about you?
Hey, Kurt,
Mm-hmm.
on this one, is there some way that we can put the, like you, me, and Zhang's up at the top?
Some some way with pinning. I don't really know. I don't know this system that well.
Yeah, neither do I.
Yeah. Sorry. Why is it not showing? There we go.
Oh, oh, there you are. Hey, Kurt.
Yep.
Yeah, when Felix gets on here, we got to. I'm gonna kind of give him a hard time. I was on the phone with him last night at about midnight, and he's in his room up at the Air Force Academy, but his roommate calls from another building and said he'd have to sleep in that building because there was a bear outside.
Mm.
Colonel
Wouldn't
30
surprise
Acre.
me.
Colonel 30 Acre.
Go ahead.
I want to say thank you for the book recommendation. I got the Lost Person Behavior book,
Mm-hmm.
and it's very interesting how they have taken all that data and pretty much tells you in the book what to look for, where to look for it.
Yeah. Like I said, that's what the guy did. He basically just compiled like tens of thousands of searches over the years and basically put together basically into a database before databases existed. Because he wrote this thing like in the 70s or 80s.
Right.
So
Yeah, and it was over like 34,000 missions or
yeah.
it's very interesting. Thank you very much for that.
Yeah. I mean, it's not exact science, but it's pretty close, you know, to where if you kind of track the behaviors and everything, where you find people is pretty much in that zone he says. So it's fairly accurate. That's why it's a good thing to have in the toolbox for search planners.
What book was
Absolutely.
this, Kurt?
The
Lost.
I can't remember the author top of my head. It's the what we used to call the Blue Bible in the emergency management. Basically, it's Lost Person Behavior. Basically, this guy compiled.
Oh yeah, I've got that. When EMA taught that, we used to get it.
Yep.
Robert Kester is
Yep.
who wrote it.
And like I said, it's not a requirement to have, but if you're going to get into this pretty regularly and want to kind of advance further up the chain, it's probably something good to have. It's not like the lay ground team member needs it. It's more for like planning staff. It's it's good information.
I'm sorry, I just joined the conversation. What book are you talking about?
Kurt?
It's called Lost Person Behavior. Let me put the link to it. Give me a second.
Yeah, I just touched on that last week, and Kurt came up with let everybody know about that. I just mentioned what was in the ground team leader text,
Yep.
or ground team member text.
Yeah, I just put it in the link. It's basically a book that this gentleman put together out of like 30 some thousand searches. He basically compiled data to figure out where are people being found, and kind of put some mathematical calculations together and says, if a person, it's this characteristic, like they're a avid hunter, where would they possibly be found in this vicinity? And basically, he just tracked all the data of searches from 30-some thousand searches, and basically put together a mathematical formula and basically said, if you're looking for a hunter, they'll probably be in this general range, and most of the time they are. So it's a good tool to have. So yeah, I just put it in the chat. Nothing's showing.
We get that black screen again. That's your presentation's not up there. There we go. Now it's showing.
No, maybe I have to stay. You still seeing it now?
Yeah, it's still showing.
Okay. I'm still trying to understand the system, so I guess if I hit the wrong tab, it kicks it out. So I think I see a few new names. If you guys are new, welcome. If everybody could please, if they have not done it yet, go to the chat feature and sign in. That way we can kind of get an accountability from people. I think I see a few new names popping in here and there. Oh, 37. I don't know. We had like 60-some last time. Maybe a holiday weekend. People are still traveling or something.
Hey, Felix. Cadet Zangs?
Yes, sir.
Yeah, where are you transmitting from?
Just from my room.
Okay, you see any bears?
No bears right now.
I told my wife that, and she said, "Where does he go to school?" We'll get everyone, what, to about 5 after Colonel 30 Acre?
Yeah, I kind of gives people a few minutes.
Okay, I'll a little introduction, and then tonight is going to be Cadet Zhang. He put a lot of work into this one. Hey, did you get dinner?
No, not yet, but
Is he bringing it to you, or do you have to run away?
we'll see. I'll turn around and find out.
Luckily, Cadet Zangs and I are both night owls. We've been working on this sometimes midnight, 1 o'clock, and a midnight here, 1 o'clock where he's at.
We said a few people joined.
I thought he was in Colorado or something. Wouldn't he be an hour behind, not an hour ahead?
Yeah. What time is it there, Felix?
It's 6:03 right here, so an hour behind.
Oh, yeah, it's an hour behind. Sorry about that.
No worries.
Now, while we're waiting a couple minutes for everyone to sign in, everyone should have some type of notebook and a pen. You're going to need to take a lot of notes.
And these slides are available in the folder. I can paste a link to them in the chat, but they are available from the course handout as well. So if anyone wants to reference these slides later or follow along on your computer screen, feel free to do so.
right, still a minute shy. I haven't really heard any more dings here.
Okay, we're up to 57, so
57.
yeah, I'm seeing 57 on the chat.
Mine says 49. That's weird.
Oh, 49. I don't know. Yeah, the chat says 57.
That's odd.
Maybe,
Yeah, Ron
maybe
Zach was on the phone.
what's that?
I said Ron Zach was on the phone. I can't get the link to work.
Okay, we got you, sir.
Thank you.
Colonel Taylor, the 57 may just be the number of unread messages.
Oh,
So
that's
if you
fine.
click on the
Okay.
chat and scroll all the way down, that may be what's showing.
Okay.
That would make sense.
All right. Okay, it's 5 after.
Yep.
Let's get. We got a lot to cover tonight. Hi, this is Lieutenant Colonel Taylor again. Tonight is going to the task will be on the different map reading. Now, Cadet Zangs and I, we had to think about how we could do this virtually. Thank goodness that I have a cadet that knows how to use a computer. This is all him. Again, you have every time we change to a different task, you have to sign in so that you're on there if you want to get credit for it. So other than that, and now we've been doing pretty good. As I get as you enter your tasks into Ops Quals, I've been signing them off. When I first got on this, I was up to date. So we're doing a pretty good job with people getting their tasks in and then getting them signed off.
Yep.
Cadet Zangs, it's all yours.
Well, one quick thing.
Oh, wait.
Sorry.
Okay.
When you are entering the task information into the chat feature, please wait until I enter it or Cadet Zangs or somebody, because people keep doing it before we finish with the topic, so it kind of throws things off. So wait until it's entered by myself or one of the other instructors, because it throws things off sometimes. So just so as long as it's in there too. Yeah. So go ahead. Sorry, good.
Cadet Zangs, it's all yours.
All right. My screen should be presenting, and I'll start off with the Wi-Fi here is very interesting. So if I get kicked off or something, I'll be back, but I might get kicked. So without further ado, let's get the presentation started. Okay.
Am I still showing my screen?
No, I stole it from you, sir.
Okay. Instead of still showing, that's why I wasn't sure. All right, sorry.
Okay, so cool. Quick overview. We're going to go through a couple of different types of maps. We're going to go through locating a point on a map using the cap grid system. We're going to go over more on topographical maps, so how to identify the major terrain features, topographic symbols, elevations, map and compass, azimuths, and we're going to go over how to move from point to point in a vehicle using a map in a slightly non-traditional way. And then we're also going to go over task L003, which is employ appropriate radio frequencies repeaters, which for you guys who attended the MRO class on Friday, you guys probably already got this one signed off, but we have a different version from what they're covering because we are focused on the ground portion of this. So that's a quick overview of what we're going to do today. Okay, and rolling right into the types of maps. So on the right here, you can see a sectional chart. These are used by aviators. So this one right here is a short snippet from the Las Vegas area. You can see right in the middle is Las Vegas Airport. It's labeled McCarran International, right? And just from this chart, I can tell a lot of things about the Las Vegas Airport. Right. So again, very useful for aviators who want to know about the control tower frequencies, the weather, terminal and terminal information, the types of airspace they're going to be flying in, the runways, you know, whether the airport has a rotating beacon or not, whether it has a VOR, which is a navigation aid, what the field elevation is, and a lot more information. So everything that I just said right there, I can tell from this chart about McCarran International. right? So very useful for aviators. But you guys on a ground team might be working with that at some points. Now, second type of map that we're going to cover today is just a normal road map. You're very familiar with these. You go on Google Maps and this is what you see, right? So this is of the exact same area from before. You can see the airport is actually right in the center right here, right? But you can't tell about, like all the different information that I just named from before. What you can tell though is you can see road names, town names, right? Different districts and stuff like that. So different usage here. And then we have the topographical map, right? So there are a bunch of different types of topographical maps. Everyone uses them and everyone makes them. So this specific one is from All Trails. It's a hiking app that I like to use. But the USGS, you know, the military, everyone makes their own maps and they all follow sort of the same conventions, right? So topographical mappers, right, are useful for hikers, ground teams, and you can get a good feel for how the terrain looks, right, and what features you might be encountering. For this map specifically, right, there's a trail that I like to hike. It is this one going up to the lake down here. This was back when I was in Salt Lake City. So I did enjoy that trail, but from this, I can see the distance of the trail, right? I can see the elevation gain, whether I'm going to be walking in a valley or on the side of a mountain. I can see the rivers, lakes, roads, everything from there, right? So we'll cover this a little bit more later, but this is just a short introduction. Now, there are a lot of different ways to locate different locations on maps, right? And one of them that we use in Civil Air Patrol is the cap grid system. So cap grids can be used to plot or communicate points on the aeronautical, road, topographical maps, essentially actually any map that you have the overlay on top, right? They were originally designed for aeronautical charts, specifically the VFR sectional, but they can be adapted to any map that has latitude or longitude markings. And the reason I say that is because each cap grid is a 15-minute latitude by 15-minute longitude, I guess, rectangle that can be identified with 3 letters and a number, right? So the grid ORD 110 refers to grid 110 out of the O'Hare sectional, right? And for those of you who are not familiar with latitude and longitude and those measurements, right, 1 minute of latitude of longitude is equal to 1 nautical mile. Each nautical mile is about 1.15 statute miles, right, which are the miles that we use for everyday navigation. So one box of 15 by 15 minutes or 15 by 15 nautical miles is about 17 by 17, I guess, regular miles, right? And then for more clarification, each degree of latitude has 60 minutes of, I guess, latitude. So 1 degree is 60 minutes, and then in each minute, there are 60 seconds. So it kind of works like a clock. It's really weird, but we'll have a little more on that later. Let's see. All right, so this is just a short example of Civil Air Patrol members using the cap grids. This is from Civil Air Patrol Volunteer Magazine. So basically they are used, right? So how do these grids work, right? So each grid is divided into 4 quadrants, A, B, C, and D. And they run in a roughly, or they run in clockwise orientation with A at the upper left, right? So you can see right here, we have box 83. It's just generic grid number 83, right? Now, if we want to identify what is at that red, or where that red X is, we first go to the biggest quadrant, right? So we know that it's at 83A, right? Because it's in the upper left quadrant. And then we can further divide 83A into more quadrants. So you can see in the smaller picture in the center of the slide right here, right? We can see that 83A is divided into A, B, C, and D. And the X is in the D quadrant of the A quadrant, right? So we can say that it's at 83 AD. And then we can go furthermore into that, right? So if we divide this small little box into more quadrants, we know that it is in the upper left quadrant. So it is in 83ADA, right? So we'll have a couple more examples coming up here just to make sure everyone's on the same page about that. So here's a cap grid overlaid on a roadmap. This grid right here is SLC 116. So it came from the Salt Lake City sectional, and it's grid number 116, right? So you can see the star right here is at SLC 116 DC, right? And hopefully these next couple slides will describe how we got to that conclusion that it's at SLC 116 DC. So first we divide the SLC 116, the big box, into the quadrants A, B, C, and D, right? And then within the D box, right, we can further divide it up into another A, B, C, and D, right? And once we know A, B, C, and D, okay, now we can identify it's at SLC 116 DC. Now, if we wanted to go even further into the details, we can say that's at SLC 116 DCD because it is in the lower left, or sorry, lower right quadrant of the C box right here, right? So in case you guys were wondering, right, that's the same thing on a sectional. I know this is harder to see, but I kind of blew it up on the left for you guys. That's the same grid, number 116. It's also from Salt Lake City. And you can also see there's a faint A, B, C, and D marked off on there to help you guys, right? So with this one, we can identify, oh, that is Idaho Falls Regional Airport there. And you can see on the sectional, I circled it and boxed the name of the airport. So I see a question. Let's see, what is a point is right on the line between the quadrants? You have to make your best guess there, right? So if it's right on the line, you get as close as you can, as close as possible. The SLC DCC, let's see, what's your question right there? We'll come back to that.
I'm sorry.
Yep, go ahead.
Okay. So you said it was SLC DCD, but then I think it was a mistake when you said that. Can you please clarify the last slide?
Oh, yes. So it is SLC 116, right? And then you have SLC 116. It's in the lower right quadrant of the big box. So that's SLC 116D, right? And then you can further divide that D box into A, B, C, and D. So now you know it's SLC 116C, or sorry, DC, right? And I don't have it written on here, but you can further divide this C box, right, into quadrants. And you can tell that this star is in the lower right quadrant of the C box, which means that it is in the D quadrant there. So the full thing, if you wanted to go down all the way, is SLC 116 DCD. Now, theoretically, you can keep on going on forever, but usually we don't require that much precision. Cool. So now we got a little bit of practice, right? So I'll give you guys about 30 seconds to find the cap grid reference for the Bingham Canyon mine, which is down here, right? The town of Magna up here. I want you to find out and write the cap grid down to 2 letters for each of those. And then find which town is closest to the cap grid referenced by SLC 500 DD. So yeah, give you guys 30 seconds to do that, and we'll review the answers real quick. And please also don't post them in the chat. It's supposed to be just write them down. We'll go over the answers and you can review them individually. And yeah, 30 seconds is about up. So we'll start to go over the answers right here. So yes, the answer of Harriman was correct for SLC 500DD. And if you look at the other grids, you can see that the answers, at least that we got, were SLC 500CD and SLC 500BA. So anyone have any questions on how we got to those? Here's a better diagram of that. Nope. All right. So we will move on, and it is actually time to enter it into the chat. So please follow the format. Makes my life a whole lot easier when I'm trying to find your information. So please put O-0205, your name, your CAP ID. And, if you guys have any questions, please unmute and ask. Give until the clock hits 21 for everyone to get that in.
I have a question, sir.
Yes, go ahead.
So I got the email about the recording of these trainings that Kirk sent out, and when I went to go onto the Illinois Wing or the national website, I was unable to open them. When I hit the link thing, and I went to the Illinois National Wing website, it said YouTube that it was private, and I was unable to open it.
Okay. I am not familiar with that, but I'm sure Colonel 30acre got that. So he can try to work with you individually or respond right now, I guess.
I'm not sure on that one. You should have clicked the link and open it, but I'll look into it.
Stay on after the class, and we'll see what's going on.
Okay.
Okay. All right. Any more questions about this task specifically? Otherwise, we'll move on. Okay. So, so here's our section on topographical maps. So this is more on topographical maps. So the one that I have listed right here is a USGS, or US Geological Survey topographical map. They produce these in 7.5 minute increments, or in quadrangles as they call them. So this one right here is of my area, and we'll take a look a little bit more about what is on that. So in the upper right hand corner, we can see it's the Palmer Lake quadrangle, right? It is in the Colorado, El Paso County, and this is a 7.5 minute series map, right? Down at the bottom left side of the map, you can see a little bit more about who it's produced by, right? Produced by the US Geological Survey, the datum and projection. So the datum are NAD 83 and WGS 84, and it's projected, right? So the projection means how do we turn the curved surface of the Earth into a flat map, right? So that's the projection. And it also gives us information on the US national grid system. So it's the US grid system is another way to divide up, I guess, everywhere into different grids. So you can see this one is grid zone designation 13S, and the square ID is ED. So if you were going to reference this using the grid system, you would be 13 Sierra Echo Delta, right? 13 SED, and then whatever that grid system is used. So that was used on GMRS and stuff like that. We're not going to get too much into that, but just for your information there. We also have a scale right here. So the scale is 1 to 24,000. Basically, every inch is on the map is equivalent to 24,000 inches on the ground, right? And it also gives you a couple scales down here, right? So you can see that, hey, each meter is going to be that far, at least on the map, right? And each mile is going to be that far on the map, right? Same with thousands of feet and stuff like that. Another useful piece of information right here is the contour interval. So we'll get into contour lines later, but this is important if you don't want to do a little bit of math to find out how the elevation changes based on each contour line. So down at the bottom right-hand corner, right, we can see a couple more things, right? We can actually see the latitude and longitude right here at this bottom corner, and this matches up really nicely with the 7.5 minute quadrangles. You can also see the road classifications. So all the roads that you see on this map are identified using these symbols. We can see that the map was from Palmer Lake, Colorado, right? Matches with what we saw up top. And we can see the adjoining quadrangles right here. This one is important. It will be on your quiz. So be sure to pay attention to this part, right? So we are in this quadrangle in the center, right? Palmer Lake. Now to the northwest, we can see there's one. That's Dakan Mountain. And to our north, we can see Larkspur. And to our northeast, it's Greenland and so on, right? So those are just the names of the adjoining quadrangles. Because what happens if you're going, and you need to go over here, right? This is telling you which quadrangle you need to look at. So this is just a section from the map, right? So this is USAF Academy right here. This section is actually just north of where I am right now by about a mile or two. But we can see a couple of useful colors, right? So we'll go to here. Black, man-made or cultural features, right? Blue, it's used for water, so this should make sense. Brown is used for contour lines. Green is used for woodland cover and vegetation. Red, important roads and highways, and purple is used to show revisions from previous map editions, right? So if we can see, going back right here, we can see black, right? So black is, actually I had a better map somewhere else, so we'll get to the black later, but you can see some of the roads right here, right? The other one was blue, so blue, hydrological features, right? Water, so you can see Dead Man's Creek runs right here. Here's Dead Man's Lake, right? Stuff like that. And you see brown, all these contour lines, those are all brown. And we don't see any red on this one. So, or purple. Okay. Yeah, saw a question. Can you get these maps off the USGS website, or do you have to buy physical copies? Everything that I have on this slideshow is from data.gov, which I guess hosts all these maps. So you can find all these maps. You just have to search for it on Google and stuff like this. So yeah, so this is just a USGS map that I'm using right now. Okay, so on these topo maps, yeah, I guess I labeled them right here, right? The brown, the blue, the green, and you can see Road 106 is labeled down here. Now, the next slide, you can see the highways that I'm talking about, right? So red, remember, was used for important roads. So that's I-25 right there. Here's black for Regis University, right? And that's a notable landmark right there. And you can see roads here. That's Woodman Road. That is an important thoroughfare around here. So now that's our intro on topo maps, right? Now we're going to get into some of the tasks, right? So one of the tasks is to identify terrain features. So from these maps, you can actually identify hills. So hills will look like these. It'll look like concentric circles, and the top of the hill is usually specified by, you know, one closed circle. Now you have to be careful because sometimes it can confuse these with like a bowl inside a valley, but usually you can tell if you look at the bigger picture. So if you look on an actual map, right, I went and identified a couple of hills on this map. There are a lot more hills than this, but you can see right here, it's going up to here. And there's another hill right here. There are actually two hilltops in the upper left here, and we'll cover what the area between them is in a moment. right? And down here again, there's another hilltop, there's a hilltop, there are hilltops everywhere here. It's Colorado, so. We got more terrain features, right? So valleys, right? Valleys they go up in 3 directions, down in 1, and there's usually a river or stream that flows through it, right? So it's kind of hard to see on this example right here, so we'll cover some valleys right here. So you can see all the valleys that I have listed actually have a stream running down the center of them, right? And one other way you can identify valleys is you can see they kind of form a V shape, right? If the point of the V is pointing to the higher elevations, that's going to be a valley, right? This is going to be contrasted with ridges, which we'll go over next, right? Ridges, the point of the V will point towards the lower elevation, and I'll show you what I mean. So here's a ridge, right? Ridge is a line of high ground, and you're going to see right here, this V right here is pointing towards the lower elevations right here. So if you see on the map, right, these are ridges, and you'll actually see them kind of right by some of the valleys. So you can see ridges everywhere, right? This one to the right is not very well defined, but you can still tell that is a ridge. Okay, and these are everywhere on the map. Now, back to the little thing that I mentioned before, the little point between 2 hills. So that's a saddle, right? So think of a saddle like this middle of a Pringles chip. For you guys who are really interested in math and calculus and stuff like that, right? This is exactly what a saddle point represents on a graph. So, but basically it is a point where where the terrain goes down in 2 directions and up in the other 2. So how can you identify 2 saddles? Well, basically find 2 hills, and the point between them is going to be a saddle, right? So this area in the upper left that I mentioned before, you got 2 hills there, but you got a saddle point right in the center. And then this area in the lower left, right, you got 2 hills right here, and the saddle point is between them as well. And in the center, right between the 2, between Cathedral Rock and that other big hill, there's another saddle point right there. Although it is a much more unbalanced saddle point than the other 2. And then finally, out of the terrain features that I guess we need you to know for ground team is the depression, right? So depressions are a low point or hole in the ground. Terrain goes up in all directions. Basically, think of it as a big pit, right? Or cliffs going down. So these are indicated by hash marks, and the hash marks will always go towards the decreasing elevation. So here is a massive hole in the ground. You can see in the center right here, it is full of this depression stuff, right? This is a little enlarged image from the center, and you can see big depression, right? And you can see from the little contour line markings, right, at the bottom, it's around 5,600 feet. It even goes lower, right? We know the contour lines are in intervals of 40 feet. So at this bottom depression marking or bottom contour marking, we can tell that it's 5,600 minus 80. So that's at 520 feet, right? Contrast that with hills to the side, right? The hills to the side go up to 8,000 feet. So this is a massive pit, right? And in case you're interested, that's what it looks like. Okay. Right here, you can see on the left side, there's a dump truck. This arrow is pointing to a dump truck at the bottom of the pit. So this is a big pit, right? So yeah, that's basically, that's a massive depression right there. Now, elevation and contour lines, right? So you can see from these contour lines, basically every point along one of these lines is going to be at the same elevation, right? So you can see I have this 6,800 feet in a box, and every point along that line is going to be 6,800 feet, right? And then we can tell when we're going to the left, right? In this case, when we're going to the west, we're actually descending, because we can see the 6,400, 6,200, right? It's going down. So each of these lines is going to be in an increment of 40 feet. Now, from this, you can also tell what it's going to look like between lines, right? So you see this red 6600 or 6660 right here, and we can tell that it is 6660 because it is between the line of 6680 and 6640. So any questions on those things? And for these couple things, you can find plenty of YouTube videos on these. You can find plenty of resources with, you know, military guides and stuff like that. They're all posted over Google and stuff like that. So if you need clarification later, you can feel free to look back at these slides or at one of those sources. So here's one slide that I very unashamedly stole from some Army ROTC unit somewhere. And this one shows 10 different terrain features, right? We only covered 5, the first 5 that are listed on here, but you can see there are a lot more terrain features that you can tell from a map. Just for fun right there. So now, yeah, we're gonna enter the tasks into the chat now. So please make sure you use this format down here. Please do not combine names. I know some of you are sitting together, but please make sure everyone is separate.
Are there any questions why people are signing them, entering the tasks?
Okay, and if there aren't any questions, I'll let people keep on entering, and I'll say that the quiz is going to be based on a lot of these things that I just presented in the PowerPoint, right? So inside in the quiz, we're going to ask you to identify which points are, you know, hills or valleys or ridges and stuff like that. So please make sure you know what those look like on a map.
And I was going to say, we went through it awfully quick. I apologize for that, but like I said, go out, look for some of those videos. The best thing I can do is just say you have to do hands-on practice. Find a map. Maybe I wouldn't focus on the Rockies. Find someplace a little bit better, and just start looking at the map and just practice. This just takes experience and practice to really understand all this. So that's all I can say is you got to get hands-on.
Yep, I definitely agree. For all of you who are not in the Rockies, I do apologize, although I will say that I did choose to use the Rockies instead of perhaps, you know, Illinois, because it is easier to identify some of these features than maybe, you know, some of the flat cornfields that you may see.
Basically, he said Illinois was boring.
So I actually do have a map of Illinois that I can pull up. Here is in the Ottawa region. I guess I chose a non-boring part of Illinois. Basically, you can see, you know, there's the river is in a valley, right? And then you got a bunch of little valleys going down into the river, right? You can see the important road, right, in red, Route 6. You can see some of the areas of vegetation and stuff like that. So yeah, it's not impossible to find these things in Illinois, right? But again, if you're in the middle of a cornfield and it's all flat, it's going to be a little bit difficult. So back to the presentation. I assume everyone has gotten their stuff in. And again, we are rolling through these very quickly. I did expect more questions. So right here, it says take 5. We're going to take 2, right? We're going to come back at 40. And in this time, feel free to ask me questions or anything like that.
Hi, good evening. First Lieutenant Mongello, how y'all doing? I don't know if this is, you know, ordained to the class or anything, but I got some emails. You guys probably already know about it, but I thought I'd throw it out there that Hawk Mountain is doing some distance learning, and NISA is doing some stuff distance learning, and just piggybacking on what y'all said about reinforcing what we're learning tonight. That might be, if y'all got the time, that might be like a good option too, in addition to any other sources. Just throwing it out there.
Thank you, sir.
And when we get all back, there's a question in the chat. I think it'd be a good one to answer for everybody. I don't know if you saw that yet.
Oh, let's see. Would you give the location of buildings with cap grid or the street address of the mission base asked you for your position? Yeah, that's a very good question. So that one, basically it depends on the building, right? And depends on what you have for resources back at your base. So the cap grid is probably not going to be a very good reference for individual landmarks, just because you got to go way, way, way down to reference an individual landmark. So that's probably not the best option, right? And to plot that on a cap grid is going to get hard. The better options are, as you mentioned, the street address. We can also use lat long, right? Or if it's a very notable building, you can just say, hey, I'm right by the Sears Tower, the Willis Tower, right? So it really just depends on the type of building, where you are, what kind of resources you have, right? If you give someone an address, but they don't have a map that goes down to that kind of detail, or they don't have internet access for a Google search, right? Then the address doesn't do too much. But latitude and longitude, people can usually plot on a map, and that's always a good option.
Yeah, we discussed the task guide does say you have to be able to read maps, but remember, when you're on a ground team, this is 2020, so you want to use all the tools you have available. So if you've got Google Earth, you've got your computer, you've got your cell phone, there's all sorts of tools. So if they give you a lat long to go to, type that into your cell phone, and it'll take you there. But you still have to be able to learn to use the maps, just in case you don't get internet.
All right, thanks, Colonel Taylor. Yeah, my clock reads 42. So if there aren't any more immediate questions, we'll start rolling ahead with the second half of the presentation.
Slow down just a little bit, Cadet.
Okay. So now we're going.
Definitely slow down on this one.
Yes. So we got plenty of slides on this one. So now we're going to be covering the difference between grid, true, and magnetic north, right? So down here, right, in one of the images I showed on the topo maps was this little diagram right here. And some of you may have been wondering, what the heck is that, right? So that right there is a declination diagram. We can see that it gives us three different norths. It gives us true north, which is labeled by the star, and that is the direction to the North Pole, right? It gives us grid north, which is labeled by GN. That is used by maps that are not maybe oriented towards the North Pole. So we have a diagram for that later, but that's what it is. And magnetic north, which is the direction towards the magnetic pole. Now, the magnetic North Pole, if some of you guys did not know, is actually around Greenland somewhere. So here's the difference, right? So you can see true north is at the top of the Earth right here. It's what the Earth rotates around. Magnetic north is a little bit away from that in Greenland, and it's actually moving. And we have grid north, right? So you can see in this grid over what looks like Spain and Northern Africa right there, that you can see it's not pointed towards true north. Now, in most maps, you will not have as pronounced of a difference between grid north and true north, right? You can see right here, the difference is it's 2 minutes, right? So it's 0 degrees, 2 minutes, or 1 mil. So it's really, really, really small of a difference, but they do exist. Now, here's another illustration of the difference between the magnetic North Pole and the geographic North Pole, right? So you can see the Earth revolves around the, our axes, and the axis goes through the geographic North and South poles, right? But the magnetic North Pole is in a different location. The important thing to note is that your compass, right, will always point to the magnetic North Pole. So now we see sort of a problem here, right? If your compass is pointing to the magnetic North Pole, but your maps are usually pretty darn close to the true North Pole, there's sort of a conversion that we have to do. And here is an example of some of the conversions that we need to do, right? So the conversion, or at least the difference, is called magnetic declination. For you pilots out there, you learned it as variation, right? But declination is how far off your compass reading is from the true north reading, right? How far off the magnetic reading is from the true north reading. So luckily in Illinois, right, it's pretty darn close. You can see the declination is 0 degrees, and that probably changes a little bit every year. But you can see out in Utah, right, Colorado, out, even in Washington and in Maine, right, the variation or declination is up to 20 degrees out there. So that's a big difference, right? If you go more than a couple hundred feet, you're going to be missing your targets big time if you don't convert between these two types of north, right? So to convert, right, we're going to use this saying. They say east is least, west is best. And this works for converting from true north headings to magnetic north headings, right? So what does that mean? So if you have a true north heading right here, and your magnetic declination is 20 degrees east, right? To convert from, let's say, 0 degrees true north, you're going to subtract, right? East is least, so we want to subtract. So subtract 20 degrees from 0 degrees. Comes full circle, right? So 360 degrees minus 20, we're going to get 340 degrees. So if someone tells you to go directly north based on true north, on your compass, you're actually going to try to go 340 degrees if you have a 20-degree east declination, right? The opposite is true for a west declination. So west is best, so you want to add, right? So converting from true north of 0 degrees, you're going to add 20 degrees. So if someone tells you to go at 0 degrees true north, and you have a west declination of 20 degrees, you're actually going to plug in 20 degrees on your compass, and that's the direction you're going to follow to actually go true north. So it's a little confusing, but we're going to do an example right here because these will be on the quiz, and you will have to be converting between these things, right? And right here on this map, we only gave the magnetic versus true north, but you're also going to be asked to convert between grid and true north, and that follows the exact same procedures, right? East is least, west is best. So here's a conversion example, right? We're given a true north heading of 0 degrees, 0 minutes, right? And as I mentioned before, each degree has 60 minutes inside, right? We know that true north equals 0 degrees, right? That's given. Now the magnetic north right here, we can see this MN is off to the right. So there's an east declination, right? So we want to subtract that declination. So we're going to do 0 degrees, 0 minutes, minus 7 degrees, 59 minutes, right? And we're going to get to 352 degrees, 1 minute, right? Now, to do the grid north conversion, it's going to be the same procedure. So we can see grid north is to the right to the east. If there's an east difference, and we're going to subtract, right? So 0 degrees minus 0 degrees, 2 minutes is going to be 359 degrees, 58 minutes. So a little bit little bit confusing there, but we'll roll into another example. So here's another declination diagram. This one came straight from Wikipedia, I think. But let's say that we were given a true north heading of 143 degrees, right? So we know true north equals 143. Now we see magnetic north is west, right? So there's a west declination or west variation, and grid north is to the east, right? So for the west, we're gonna have to add, and for the east, we're gonna have to subtract. So we do the exact same thing. 143 degrees, right? Plus the 19 degrees to the west, we get 162 degrees. At least I hope this was mental math when I was creating the presentation. For the grid north, right, it's to the east, so we're going to subtract. So 143 degrees minus, that 1 degree, 9-minute variation, or sorry, difference, is going to bring you to 141 degrees, 51 minutes. Okay, any questions on that so far?
So if you're to the right of true north, you add. If you're to the left, you subtract. Is that correct?
If you're to the right, if you're to the right for this grid north, you have an east, right? So east is least, so you're going to subtract, right? So if you're to the right, you're going to subtract. If you're to the left, which means you're west, right? West is best, you're going to add.
For those of us that are up here in northern Illinois, that 0 almost goes through Rockford.
So, yes. So what is meant by minutes?
Depending on your mission, you've got to know where you're at so that you can. It's not going to be that much. Those out west, they're going to just do it one way. We may have to do it both ways, depending on where we're sent.
Yep. And we had a question of what is meant by minutes, right? So we have degrees of latitude and longitude. Here's a quick Google search that I brought up, right? So the Earth, okay, is divided into 360 degrees for a circle, right? And the lines running horizontally, we call them latitude, and the lines running vertically, right, north-south, we call them longitude. And we're going to have different degrees of longitude and latitude depending on where we are. Now, each of these degrees is broken down into minutes, and further, you can break it down into seconds, right? So each degree has 60 minutes, each minute has 60 seconds. It's a little confusing, but that's how things are done. So hopefully that makes a little more sense, right? So we got this big latitude longitude system broken up into 360 degrees. Each of those 360 degrees has 60 minutes, and each of those 60 minutes has 60 seconds. So, okay, now we're going to be going the opposite direction, right? What if we're given a magnetic north heading, and now we got to plot it on a map, right? How are we going to plot that in accordance to the grid or the true north? Right, so we are going to use east is least, west is best, but we're going the opposite direction. So we're going to have to reverse that thinking. So here's what I mean, right? So if we're given a magnetic heading of 0 degrees, right, the true north we can see is or the magnetic north is to the right of true north, right? So we're actually going to have to add, right? Usually to convert from true north to magnetic north, we're going to have to subtract, but now we're going to have to add to get back to true north. Now in the slides, I have it written in an easier method, right? And that method is that basically you look at where everything is in relation to everything else. So right here, true north is to the left of magnetic north, right? So to the left is west. So we're going to just use west is best. And we're going to add that 7 degrees, 59 minutes to get from magnetic north to that true north, right? The way the task guide has it written is that your grid north conversions will always come off of true north, right? So what we're going to do is we're going to convert from magnetic north to true north first. We get 7 degrees, 59 minutes. And then we're going to get from true north to grid north, right? So we're going to take 7 degrees 59 minutes. Grid north is to the right of true north, so we're going to subtract. We're going to subtract that 2 minutes, and we're going to end up at 7 degrees 57 minutes. So I'll let that sink in for a little bit. Okay. We have another magnetic north example, right? Same other declination diagram that we see here. But if we are given a magnetic north heading of 143 degrees, how do we get to the true north and the grid north headings, right? So you can see true north is to the east of magnetic north. So we're going to subtract, right? The declination is 19 degrees right here. So 143 degrees minus 19 degrees, 124, right? And to get from true north to grid north is also to the right or to the east of true north, right? So we're going to take that true north heading of 124 degrees, and we're going to subtract that difference of 1 degree 9 minutes, right? So we're going to end up at 122 degrees 51 seconds. Is this making sense to everyone?
Speak up now. I had to ask him about 10 times last night.
All right, sorry. So when you were on that previous slide, you were saying that grid north, that one, no matter what, I'm going to say something stupid here. So magnetic north, basically, you're going back to the true north. But grid north, you always go from true north to grid north. So in this case, you're going east, so it's always going to be, because the other one will be going west. Because originally I thought that grid north would also be going west, because that you're saying, so because you always go to the true north. Then
Yes.
Okay.
Yeah, so in this case, we're going off of the true north, right? Because the declination diagram only gives the like the difference between the true north and the magnetic north, and the true north and the grid north, right? So if we wanted to convert directly from magnetic north to grid north, we would have to do the math, right? We would have to subtract 7 degrees 57 minutes, right, from magnetic north. But since we're going off of true north, right, and we see that grid north is to the right or to the east of true north, then we're just going to go ahead and subtract that 0 degrees 2 minutes. Right, so that's basically, it might be an extra step, but it's a little bit clearer, and that's also how the task guide wants that to happen, if that makes sense.
Cadet Zangs, let me interrupt. This is a safety thing. I'm reading some of the comments. There may be storms in your area. If there is a storm in your area and it's telling you to take cover, you take cover, and you can send us a message afterwards, but do not wait for, we may not see it right away. So safety first, okay?
Yep, and I see some questions about apps and GPS devices and stuff like that. And yes, you're allowed to use, handheld GPSs. You're allowed to use your cell phone. You're allowed to use all these things on your missions. Just be aware that, hey, when you run out of power, right, when you run out of reception, when, you drop your phone into a pond, right, you might have to go get out that paper map or paper chart to help with that. So now, let's see. Yeah. Thank you, Lieutenant Dyer. Yeah, I've seen conversions weren't made during a live fire at sea once a carrier missed by only 300 yards because of it. So, yeah, live fire, right? They're trying to shoot a azimuth to somewhere to go to. For us, we're trying to find ELTs, beacons, missing people, and stuff like that. So, hey, if you're off, not very good. So, yeah. On an aviation sectional, right, the same thing is labeled just in a slightly different way. So we really don't see the difference between grid and true north on an aviation sectional. We just assume those to be the same thing, right? But we can see this one is a little section from out on the border of Wyoming and Utah. And you can see there's a magenta line running through it. And from that red box right there, you can see 11 degrees, 30 minutes east, right? So this is telling you that, hey, when you're flying or when you're driving or whatever you're doing, right, what your compass is saying you're going is going to be 11 degrees, 30 minutes off of the true north heading, right? So let's say if you want to go 0 degrees true north, right, you're actually going to have to subtract that 11 degrees, 30 minutes. And on your compass, you're going to have to go 348 degrees, 30 minutes for your heading. Yeah, got a question about an azimuth. Azimuth, think of it as a fancy way to say heading, right? So if I want to go 0 degrees, right, straight north, and I want to, that's my 0 degree heading, think of it as an azimuth too. There's a formal definition, but for the purposes of this is, hey, azimuth heading, same thing. Okay. Yeah, so why does this matter, right? Lieutenant Dyer gave a great example of why it matters. For us, right, there are big differences between which north is used, right? So, when flying, right, the course of the aircraft, a lot of times when you're talking about course and you're trying to plot it out on a chart, you're going to draw that in terms of true north, right? But when you're navigating using VORs and other, nav aids and a lot of GPS systems, right, you're going to use magnetic north instead. Otherwise, right, when plotting azimuths on a map, right, say you're trying to triangulate the location of a beacon, right, and triangulation is basically you go to 2 different locations on a map and you draw 2 azimuths, right? Let me see if I can find a quick example on Google to show you guys. Right here.
Now, by the way, this is what we like. If you've got questions, otherwise we're going to breeze through this. So if you've got questions, we can slow up the presentation a little bit. So.
Yep. So this is an example of triangulation, right? So say you were at points A and B, and you knew that a target was located at B at your, let's say, 170 degrees from B, right? So you're going to draw this line from B, and then you're at location A now. Now your target is at 255 degrees. You're going to draw this line, right? And where they intersect is where your target's going to be. We'll get more into this when you do your ELTs and triangulation and stuff like that. But basically, it's very important to distinguish between these, because if you use the wrong type of north, right, to plot these azimuths, you're going to end up with the wrong point. So yeah, that's plotting azimuths on a map, right? And then your handheld GPS unit, most likely it'll show, it'll be capable of showing all 3 of these different norths, right? Or at least at the minimum, true north and magnetic north, right? But if you don't know which one is showing and you don't know how to convert between the 2, you're going to get inaccurate readings based on, or you're going to get messed up sometimes. So. There's a question, how can we read the difference between a minute and a second on a map? Most maps, we're not going to be able to go down to the second level, but basically you're just going to have to find out how you can divide each minute into 60 seconds and estimate based on that. So, yeah, it's not the easiest method of navigation, but it is possible. Okay, this covers the task of converting between map and compass azimuths, grid north, true north, magnetic north. Please, if you have any questions, pipe up and we'll try to see if we can answer those. Okay, we're gonna give a couple more seconds for people to enter.
Cadet Zhang, quick question.
Yes.
So I think I understand why I was getting confused on the left and right of the line. Can you be a little bit more cognizant when you pause of saying the word right? I think that's what threw me off.
Okay.
I just noticed several times as I'm listening, I'm hearing you pause, you right, and then
Yep.
you go on, you right, and then you go on. And that's just a habit. I know we all do it, but
Yep. I will make sure to be a little bit more cognizant of that. Although I guess moving on now, we're not going to be doing too much of the conversion between these things.
gotcha. Thank you.
Cadet Zhang,
Uh-huh.
I didn't really understand how you enter the azimuths in the map. Could you quickly go over that again, please?
You mean plotting the azimuths on the map, or
Yeah,
what do you mean
plotting.
by entering?
All right.
Okay. So plotting the azimuths on the map, it's actually a topic that we're going to cover next week. But basically what you're going to do is you take a small little protractor and basically line the protractor up with north, and then draw a line based off of the angle on that protractor on the map. So give
Okay.
me one moment and I can actually pull up a picture of that process.
Okay.
Okay, so I will be transferring over. We'll cover this in more detail next Monday, but basically these are my slides on plotting an azimuth, right? So, hey, we got a point at Raspberry Butte right here, and we want to plot an azimuth of 123 degrees grid north from Raspberry Butte. So we take out our trusty map tool, put it right over Raspberry Butte, and make sure it is in line with the grid north, right? So you can see this orange lines right here are parallel to this cross in the middle of the compass, or on the middle of the protractor. And then we're going to find 123 degrees on the protractor, and we are going to take a ruler and mark 1 or 2 points based on 123 degrees, right, with it centered on the point that we want to mark from. Then we're going to draw the line. So that's the basics of plotting an azimuth right there. Does that help?
Yes. Thank you.
Awesome. Okay, back to the original one. So yeah, navigation in a vehicle. So, or actually, before we start, any other questions?
Yeah, I was trying to say, some of these are maybe ground team 1, but if you want to, where do you get those protractors? I've had one for ages, Felix. Where can they order those from?
So yeah, the protractors, you can order them from, sites like Amazon or stuff like that. Basically, you just want to search for something like, MGRS plotter or something like that. MGRS, for you guys who don't know, we're going to go over this a little bit more, or we're going to mention it next week, but it's the Military Grid Reference System, right? So that plotter that I showed in the other slide is actually built for maps that are built on the MGRS system. But yeah, you just search for, map protractor, map tool and stuff like that, and you should be able to find these online at, map specialty stores or even Amazon. So, all right, navigation in a vehicle. So basically, Colonel Taylor and I looked at the navigation in a vehicle task and decided, hey, yeah, it's 2020, right? We're going to be able to plug stuff into Google and make our vehicle go where we want it to go. And if Google is not available, right, if we don't have internet, a lot of us have offline maps on our phone, and we can still get it from the offline maps. And if we don't have offline maps, we have handheld GPS units, and we can still get it from handheld GPS units, right? So we are very able to plot different points. So we're going to do this a little bit differently than what the task guide actually says, right? And the focus of this is actually going to be how to integrate the information around you and the technology that you have to make the best decisions on how to get to those points or how to pick those points. So let's go through a scenario, right? You get this map, right? And you need to get to the...
Felix, watch your rights, because we are talking about getting from one point to another.
Yes, sir. So we have this map, and we're trying to get to that point labeled in red right there. Right. So how do we get there? We have 3 different options. So we can choose to go to the tip of Kettle Creek Road right here. We can also choose to go to this little corner in what looks like a little, community, little housing development right here, or we can go to this tip up here. So we have 3 different choices. How do we pick the best choice? So if you look a little closer at the map, you can see that there's a stream or a little creek running through that, running through the area. And it's surrounding our area or our target on 3 sides, right? So even we have to the north a little branch of this little creek. So we really don't want to go stomping through the creek to get to this small area. So we got to pick the best point out of those 3 that can get us there on foot. And if you notice, this point to the far right is a good location, because all you have to do is go down a hill and you can reach that point without needing to cross any streams. So with our infinite amounts of Google resources and whatever that we usually have, we can also take a look at the satellite imagery. And that confirms that, hey, there is a creek surrounding our point on 3 sides, and we really don't want to go across that. And it actually shows that there's an update from when the map was drawn, that there are more roads that lead closer. So we can drive up to the tip of there and continue on foot in the green arrow. So that's just a little example of, hey, maybe this closest point. So you can see from here, the point on the left and the point right to the south of the target, they're much, much closer than the 3rd choice out to the right. But those 2 other points are not good, because we don't want to cross that creek shown right there. So here's another short exercise, and we'll also do something similar in the next lesson. But this is based on, hey, you're given a map, you got these terrain features, right? How do you tell where you are on the map? So we see Sprouts Farmers Market to our left side. We see a large road and some mountains to our right in front of us. And to our right side, we see some apartments and houses, right? So we got Sprouts on the left, mountains and a big road in front, and houses to our right. Now, okay, we know that we're in this general area. How do we locate where we're at? From the satellite view, we know the mountains are to the west, right? Because we're facing the mountains, and we know that, so we know we're looking west. We also know that we are in an urban area, somewhat urban, because we got shopping centers to our left and housing developments to our right. So we know we are roughly in this little grid right here. So we zoom in. How do we tell where we are within that little bit, right? We know we're looking to we're looking for a shopping center to the south of a residential area, We also know that we're on a major road. So the only major east-west road here that we can see is Northgate Boulevard. So we zoom in even further and we focus on the area with a shopping center to the south of the road and housing developments to the north, which is right here in this little red box. So we zoom in even more and we can see, oh, hey, Google pops up. Hey, we got Sprouts Farmers Market and we got some housing to the north. So based on that, we can tell, hey, we're at this green star, we're facing towards the green arrow, and that's, and we've located ourselves on the map. Now, I get that this is an idealized situation, right? I created this scenario. In real life, it may not be the same simplicity and stuff like that, but the general process for locating yourself kind of follows the same thought process. So after all that, so what, right? Basically, beyond merely plugging in the location that you want to get to on a GPS, we need to be able to integrate the different information available to us to make the best decision on how to get there and what to do when we get there, right? It is still very necessary to know how to reference paper maps, of course, right? But at least in Illinois Wing and the majority of the continental US and Hawaii, right? The populated areas at least, your ground teams and aircraft will have cellular data, offline maps, GPS units, combination of those. So in 2020, it is not as key for you to know, oh, hey, I'm here on a map, how do I get to another location? So evaluation for this task will be based on some of the topics we covered in this PowerPoint and on certain information within the task guide that you'll just have to open and reference. So give a couple minutes for people to ask any questions and enter your information into the chat.
Want to say that I know a lot of this probably doesn't make a lot of sense right now because the environment what we're doing this in, but once you actually get out in the field and start doing a lot of this hands-on, it'll start clicking. I know everybody has different learning styles, and that's what works for me. So it's just be patient, and I know when you're starting to open up, but when you're able to get out and start doing practicing again, start getting the maps out, this will start making a lot more sense to you guys. But
and let me add to this also. Remember, what you're learning, even on these training when we were out in the field, does not make you an expert. You've got to keep practicing. So we're giving you the basis, and hopefully you'll pass the quizzes so we can give you the task. But then it's up to you on bivouacs, on training missions, to reinforce what we've gone over on this. This does not make you an expert. I've been doing this 35 years, and I'm not an expert. I keep learning. I learned from Colonel 30 Acre. He learns from me, and I'm learning a lot from Cadet Zangs.
I just want to say that from experience, this is where we lose a lot of people on ground teams is the map type work. So just stick with it. It'll make sense at some point to where you understand the basics of it. But I've seen a lot of cadets, especially if they're younger, they get really discouraged with this part and just kind of quit. So just if you need help, you can always ask somebody. So.
For your information, I was just looking now. I found a download, and it's hold on, I gotta find it again. I got 2 compasses on my cell phone, which really come in handy when I'm on a ground team. I mean, yes, I got my regular compass, but this one, I just move my cell phone around, and it's digital. So you might want to look and see if you can find some type of app if you don't have one on your cell phone.
Okay, I see some questions in the chat about Gray Flag. Yeah, everyone has gotten one email. Unless you are involved with the incident staff, I suspect, but everyone has gotten that one email. Let's see. What will we put for the mission ID when entering task, and who will the evaluator be? Again, it is all in the course handout, which is available at this link right here. It's the same link from before, but I just made a short link so that I can keep typing it into the chat when people ask. So all the information is on that document. All right, so let's move on. This will be the last task of the day, which is pretty cool. We got through pretty quickly. So communications. We'll assume that you have a basic knowledge of communications from iCut, right? A lot of you who sat in on the MRO course also got this communications section right here, but we're going to cover just a little bit different things, and it's going to be more focused on ground stuff. So, and yes, Gray Flag is an Illinois wing thing. So from the task guide, right, ground search and rescue teams use a number of VHF FM frequencies to communicate with mission-based other ground teams and aircraft. We'll go into more what VHF FM is later, right? But most of these things are going to be assigned by a communications unit leader. So all your frequency assignments when you get onto a ground team or to an air crew are going to be given by the COL or COML, depending on which terminology you're trying to use. So in general, Civil Air Patrol uses a couple different frequency bands for communication. So we're going to see very high frequency modulation, right? VHF FM. In recent years, we've added on P25, which is a digital mode, and digital just has, digital usually performs better than normal FM. Just better technology. We'll keep it at that level for now. We also have VHF AM, right? Very high frequency amplitude modulation. This is what the pilots are using to talk back and forth between the ground, other aircraft, right, and themselves. Civil Air Patrol does not normally use VHF AM to talk between Civil Air Patrol assets, but the pilots flying in the planes will be using that to be talking with non-Civil Air Patrol assets. We also have ultra high frequency modulation, UHF FM. Those are the ISR radios. So those are the really, really tiny walkie-talkies that you see sometimes on flight lines and in other activities. And then we have high frequency single sideband HF SSB. So in Civil Air Patrol, the majority of communications will be done over VHF FM or VHF, the P25 on the same frequencies. You'll see also a lot of HF use, right? High frequency use, but that is for a different purpose. So in ground teams, in what you'll usually see is VHF FM or P25. Now, a little bit more about VHF FM or P25. So there are 6 simplex channels. And if you guys remember from iCut, right, simplex just means that you transmit and receive on the same frequency. You got CC1, CC2, Air 1, Air 2, CapGuard, TAC1. Okay. The names only suggest their usage, right? So CC1 is suggested for the first command and control channel. Air 1 is suggested for air to ground use, right? And stuff like that. But the communications unit leader, the COL or COML, has discretion on which of these frequencies to assign for what. So sometimes, right, I'm a COL, and sometimes, in training, I've never actually had this happen, thankfully, but in training, we've been given scenarios of, hey, what do you do when the incident commander says, we will use this frequency for this purpose only, right? And basically the communications unit leader will say, no, sir, or no, ma'am. Respectfully, we will set the standard. So the takeaway is listen to the communications unit leader, right? And these are the simplex channels. Now we also have repeater and liaison channels. So repeater, if you remember from ICUT or MRO training, means that you're transmitting on one frequency and you are receiving on another frequency. And why that is you're oftentimes going to be talking to this, nifty device called a repeater. It's usually at a high location that can receive very good signal. And you talk to the repeater, and the repeater is rebroadcasting out everything you're saying at a higher power to a larger area. So that's why those are very useful, right? My little handheld radio in Illinois can maybe get me, 5-10 miles in good conditions, right? But if I bounce it off the Willis Tower or bounce it off a Fermilab or bounce it off of a hybrid, right, in a plane flying a repeater, then I can go a lot further than that 5 to 10 miles. Out here in Colorado with the mountains, that's, my handheld, and even in a car, a mobile radio, that's reduced to, half a mile, 1 mile. So repeaters are very, very important. So repeater channels are identified using the R, right? So all repeater channels will have R01, R02, all the way through R64. Those are the land repeaters. Those are fixed and in their individual locations. So you'll notice that R41 is on top of Fermilab in the Chicagoland area. R25 is at top of the Sears Tower or Willis Tower in Chicago, and those are between 1 and 64. Whenever we go out to another mission location and we need to set up our own portable repeater, right? What if we don't have a repeater around us that we can use, or what if we want a separate channel? Then we set up what we know as a tactical repeater. And those channels are going to be R67 through R70. So whenever you're talking through a hybrid, whenever you're talking through a repeater setup at a remote mission base, these are going to be R67 through R70. That P25 thing that I mentioned from before, that's just signified by this P at the end of the channels. So all repeater channels, and also, I didn't mention this on the previous slide, right? All simplex channels, all of these channels have a digital version that you should be using. Cap regulation 100-1 or 100-3 actually tells you that digital is preferred, right? So all you need to know is if it has a P at the end of the channel name, it is a digital channel. Now, we also have these things called liaison channels. So these are used to talk between Civil Air Patrol and other agencies. So what if we're working with a local emergency management agency or the state police or something like that? We are going to be using different channels that they have and that we have to be able to communicate. Because more than likely, right, your local sheriff is not going to have Civil Air Patrol channels programmed into their radios, but they are going to have this common frequency, these liaison channels that they can switch to and that we can switch to be able to talk together. Note that these are only available by invitation from the other agencies or by previous understanding, right? Sometimes we have MOUs, memorandums of understanding for this purpose, and they are only for use between Civil Air Patrol and outside agencies. So if I'm on a ground team and I want to talk to mission base, even though I can switch to a channel such as VTAC 11, we're not authorized to do that. So just keep that in mind for liaison channels. Now at Illinois Wing, we have a standard communications briefing form. There is an aircrew version as well. This is for ground team. The aircrew version will show the TDFM 136 aircraft radio in there, but this is what you will receive, or this is what the ground team leader will receive from the communications unit leader before going out on a mission. So at the top, you can see we have the ground team name, right? The mission number, sortie number, the crew cell phone number in case the radio goes down, who it's prepared by, what we're trying to do, right? It's a ELT search and where we're trying to go. This one says it's 25 miles west of the incident command post. So based on that information, you're going to, the communications unit leader is going to assign channels in the proposed comm plan box right here for the ground team to use. You're going to have, so for in this specific example, we have CC1P as our primary base or local channel. So while the ground team is getting ready, doing their vehicle checks, doing everything before going out to base, they're going to call on CC1P. The alternate channel is CC2P. When they're going outbound, right? So when they're departing mission base or the staging area to go to their objective, they're still going to use CC1P. And then at some point in the middle, they're going to switch over to R25P. And remember, R25P is a repeater channel, so that's going to give them a lot more range and a lot more capability to talk back to base. We saw that the objective was 25 miles west of the incident command post, so we do want to use that repeater to our advantage. When you're in grid and searching, right, if you're R25P, if you're not able to contact mission base on that channel, you can try another repeater. In this case, we assigned R41P. And then when you're coming back in, you're going to stay on R25P and R41P until you get back to base. And then when you're back at base, you switch over to CC1P or CC2P. And the reason we have these different channels is so that we don't tie up the repeaters, right? In a larger scale exercise or mission where you're going to have 3 to 5 aircraft flying, you're going to have a bunch of ground teams out there. If everyone is trying to talk off of R25P, it's going to get really, really congested. And if everyone is trying to say, hey, mission base, you know, our starting mileage is 32,000 miles or something like that, nobody in grid while they're doing searches, nobody wants to hear that. So that's why we have these different frequencies assigned. So in this case, we can identify the primary simplex, duplex, or repeater frequencies, and the ground-to-ground frequencies just based off of this this chart right here. So again, these are some notes about this specific task, right? As a communications unit leader, as the one handing out these frequencies sometimes, the task guide is outdated. There's a section where it mentions you can program frequencies into the radios. We don't do that, right? The radio is given to you by the communications unit leader, by your communications officer, with all the frequencies programmed in. So whenever it mentions like 100 hertz tone in the task guide, you don't need to worry about that. What you do need to worry about is, in the vast majority of cases, the communications unit leader is going to brief your team, right, your ground team leader, to as to what you're going to do, right, what frequencies you're going to use and stuff like that. So that is a good time to ask questions on other notes right there when they're briefing you. And
let me
yes, sir.
interrupt 1 minute. On that form you had up there, is that a CAP form now? Is there a number for that?
That is not a CAP form, but it's available on the Illinois Wing Communications page under Communications Documents. So I'm going to paste the link in the chat right here. And you can find, that's called the Ground Sortie Communications Plan. There's also the air crew version for you pilots out there who want to take a look, or pilots and air crew. And there are also some other useful resources such as the quick reference. If you go to the bottom of that page, actually, I'm just going to share this tab right here. The quick reference right here.
For those of you who are out of state, check with your state to see what kind of form they use. This is what we use in Illinois.
Yes. So yeah, and you can see this is what the EF Johnson radios should be programmed with. That is the channel plan. So all of these are available there. Before we move on, let's see, there's a question, are these channels on the slide only applicable to Illinois? So if we go back to the slideshow, these channels right here that I list in the 6 simplex channels and the VHF FM P25 repeater channels, everything that's listed on these 2 slides, 75 and 76, they're nationwide, right? Now, your area might not have a repeater 25, right? R25 is on top of the Sears Tower. But you know, for you guys down in Southern Illinois, you're going to have repeater 3, and stuff like that. So it just depends on what is in your area. And again, your communications unit leader is going to brief you before you go out on a ground sortie. So this time, are there any questions? And please enter your information on the chat. So I have a question. You see that this and the last presentation will be the primary source for the quiz questions. The links in the handout just bring on the task guide. So if you go to the virtual course handout, I know I just took it off of there, but just click on this link for customized PowerPoint slides. So these customized PowerPoint slides will take you to a folder that I'm bringing up right here. And you can see this presentation right here, day 3 presentation slides. So they will be available for everyone to see the slides. And I have a note. I have a couple of slide or speaker notes in a couple of the slides, so you'll be able to see those as well. So I'm going to give a couple more seconds for people to enter their task information and to ask any questions. This is our last task. We're just going to go over a couple more just administrative things and some quiz feedback items before we let you guys go. And if you guys have individual questions or comments or anything, feel free to stick around afterwards as well. So, okay, quizzes. The day 2 quizzes are still open. So if you have not done the quizzes from last Monday, please make sure and go and get those done. If you do submit it late, please send me an email so I know to go plug in all of those scores. Another note, remediation information is available on the last page of the course handout. Please follow that guide. We have some people resubmitting some of the old quizzes. Please do not resubmit the first round of quizzes because those are one submission only. The retake quizzes, you can submit as many times as you want until you get 100%. But that first round of quizzes that we post for each day, those are one submission only. So please follow that information. It'll make our lives a lot easier so that we don't have 50 people doing separate things. And then, if you see absences in the student tracker, please continue emailing me about those, clarifying stuff like that. We will work with you to identify, credit, like options for credit and stuff like that. I saw a question about I took a quiz before the due date. It says not graded, not completed. Probably is just a mismatch in the cap ID you entered, because all of the information is pulled based on cap ID. So send me an email about that and we'll take a look. Finally, we have some homework for next class. So the homework really isn't homework. We just need you to print out one sheet of paper. It's the CAP Form 110. It's very easy to find. Just in Google, you can search CAPF 110 and it will pull up a PDF copy. If you can't find that, it is also in the course handout for you to use. And yes, print out. That is correct. We need you to print a paper copy because we will be grading your handwriting and stuff like that in the presentation or when you submit it.
That's next week. We need that for next week.
So who has a printer? I don't know. Go ask your neighbor maybe. I know you're joking, but basically we are trying to avoid stuff like this on logs.
Do we have any doctors on board?
So, when you're writing your logs, we do not want to see any of these 6 types of physician handwriting. Okay, we only want to see something very close to sample D right here, the last one. If we get anything with A, B, that is not going to pass. So please make sure you print that out so we can grade that.
If any of you have ever signed the CAP Form 173 to do a vehicle inspection, my biggest pet peeve is when someone just scribbles a name on it, and I don't know who it is, I'm going to start not taking the 173 when I can't read the signature.
Yep, and for those of you who don't know, the CAP Form 73 is the vehicle inspection form. So, yes, I understand not all MDs write that bad, but some definitely do. And I also understand there's doctors shorthand and stuff like that, but mainly for an example of what not to write on a log.
Remember, some of these documents, because we have to put them into the mission folder, they are legal documents. And so they've got to be readable. If there's an incident or something like that and they've got to go back on these logs, we've got to be able to read them.
Yep, so that is all I have. Before you guys go, Colonel Taylor, Colonel 30 Acre, you want to add anything before everyone's released?
No, pretty good. Did you get a chance to eat?
Yes, sir. My roommate brought some food back for me.
Oh, okay. The chow hall's closed at the academy. Oh, wait, no, it's the DFAC, the dining facility. I forgot, your Air Force.
DFAC, yeah, DFAC. Right here, we just call it Mitchell Hall or Mitch's. But yeah, if you don't have anything else, Colonel 30 Acre, anything to add?
No, there are a couple questions. Again, if you want to, oh, go ahead.
No, I was just gonna, no, go ahead, Bob. I'll do my thing when you're done. I was just gonna say, thank everybody for coming on these last 3 weeks. I hope more people are getting something out of it, and obviously we got one more session next week. So, but please continue to be involved in these courses. Again, Wednesday we got Mission Scanner, and then Friday we're doing the second session of Mission Radio Operator. So please, if you want to participate in those, please log on. So that's all I really had.
All right, if there's nothing else, I guess everyone is released. Feel free to stick around for questions, comments, anything you want to address. And yeah, please email me with stuff as well. Okay, so let's see. How do we resubmit for ops quals? If you were initially denied on something, you can just go to the exact same place and submit it. I know I'm trying to keep up with some stuff like that. If you